In this video, we are going to be talking about the notes for condensing logarithms, and it's important for us to note that we must have the same base on both of the logs in order for us to be able to condense it down to one single logarithm. So when you are asked to condense or compress a logarithmic expression down to one log, if you see a plus sign, that means that you can rewrite that as a single log of the product of the individual arguments. In this product example, we have log base 2 of p cubed plus log base 2 of q. So we've got the same base, so we can condense this, and it's added, so we are going to rewrite this as the log of a product. So we're going to have log base 2 of p cubed q, or p cubed times q. So if you are asked to condense or compress a logarithmic expression down to a single log and you see a minus sign, that means that you can rewrite it as the log of the quotient of the individual arguments. In our quotient example, we have log base b of 64 minus log base b of 16. So we do have the same base, so we can condense this down to one single logarithm, and since it's a minus, we're going to rewrite it as the log of a division problem. So we'll have log base b of 64 divided by 16, and we can actually simplify that to log base b of 4. Now let's take a look at some of these other examples that we have. Example A, we have 5 log base b of x minus log base b of y plus 1/4 log base b of z. So first of all, every single log has the same base, so we can condense this. And so now we just need to look at the steps and what it's going to take to do that. So what I want to do first is to get rid of the multipliers that are out in front of those logs by applying the power property. So I'll rewrite 5 log base b of x as log base b of x to the 5th, and I'll rewrite 1/4 log base b of z as log base b of the 4th root of z. Next, I'll take care of that plus sign, so I'm going to rewrite that part as log base b of y times the 4th root of z. The next thing I'm going to take care of is the minus sign, so I'm going to rewrite what I have left over as the log of a division problem, which will leave me log base b of x to the 5th over y times the 4th root of z. Next, we'll take a look at example B. In this problem, both of the logs are natural logs, which means that they have the same base, or base e, so we can condense them. So the first thing I want to do is to get rid of those multipliers out front by applying that power property. So we'll have ln of 4x minus 3 raised to the 3rd power minus ln of x to the 2nd power. And now we'll take care of that minus sign by applying the quotient rule. So we're going to have ln of 4x minus 3 raised to the 3rd power over x squared. Next up, we have some different properties to learn about. So we have the log of a base to a power, and if we have log base a of a to the power of x, that is going to simplify to x. So if the base of the log and the base of the argument match, it's going to simplify to the exponent of the argument. So log base a of a to the 8th power simplifies to 8. For our next example, we have ln of e raised to the negative t power. So we need to remember that the natural log is the same as log base e. So we have log base e of e to the negative t power. So that simplifies to negative t. Our next example is the common log of 10 to the 3k. Remember, the common log is log base 10. So if there is no base visible in the logarithmic expression, then it's automatically base 10. So we have log base 10 of 10 raised to the 3k, so that's going to simplify to 3k. And we'll finish off these notes with one last property, a base to a logarithmic power. So we have a raised to the exponent of log base a of x. That will simplify to the argument of that logarithmic exponent. So it's going to simplify to just x from our formula, because the base of the logarithmic exponent and the base of the expression are the same. So for example A, we have 4 raised to the exponent that is log base 4 of k, which is going to simplify to the argument of that exponent. So 4 raised to the exponent that is log base 4 of k simplifies to k. Example B, we have e raised to the ln of 5. So we have base e raised to the logarithmic exponent that is log base e of 5 will simplify to 5. And example C, we have 10 raised to the logarithmic exponent, which is the common log of 7t. So 10 raised to log base 10 of 7t will simplify to 7t. That's going to wrap it up for these notes. Please let me know if you have any questions in the comments below. Thanks for watching.